Today I will be doing the Prairie Massey High School round number 147. Question 5 and 6. Question 5 is asking, let Fmn equal to 2m minus 1 times 2n minus 1. And Fmn is equal to this thing here, and Mn is equal to every number between 1 to 10. Then what will be the average of the Fmn's? So we can find some examples by listing some number here. Then when m is equal to 1 and n is equal to 1, we will get a Fmn here. But m could be equal to 2 until m is equal to 10. And n could be equal to 2 until 10. So when they're both 1, 2 times 1 minus 1 would be 1. And the other 2 times 1 minus 1 would be also 1. And the n would not change because 2n minus 1 is still the 2n minus 1 here, but the m would change. So it would be 3. And since 2n minus 1, it's just all the odd numbers, so we know the pattern. It will be 5 and 7, and so on until 19, because 2 times 10 minus 1 is 19. Okay, so using the same logic, we can figure out that 2n minus 1 would change. And it would be, again, all the odd numbers, which is 1, 3, until 19. And m wouldn't change. And the same applies to this rule, except this 1 becomes 3. Because this because this 2m minus 1 is 2 times 2 minus 1 now. So this 3 is, actually I should probably write it here. So it would be 1 until 1, 3, 1, 3, 5, 7, until 19. So the last number here would be 3 times 19. But anyways, we can find the pattern to every number on the list. So let's try to calculate the sum. So the sum of the numbers in this row would be the numbers here combined. But we can factor a 1 out because they all start with a 1. So this would be 1 times 1 plus 3 plus 5 until 19. And on the next row, we can just factor out 3 as a common factor. And again, it is because 2n, the 2n minus 1 term is always 3. So again, we can factor out 3 and be left with 1 plus 3 plus 5. Until 19. And if we look at the pattern, this would be 1, 3, and then 5 until 19 times 1 plus 3 plus 5 until 19. And now we can factor out the 1 plus 3 plus 5 until 19 part out. And then, because they're the common factor, and then have this multiplied by this to get the sum of all of these numbers. So this would be 1 plus 3 until 19 times 1 plus 3 until 19. So this thing squared. So what is 1 plus 3 plus 5 until 19? We can use a formula that adds the first number and the last number, divide by 2, and multiply by the number of terms, which there will be 10 terms. And the 1 plus 19 plus divide by 2 times 10 would be 100. So we know this thing here is 100. 100 squared would be 10,000. And there is 10,000 terms that we're adding up because there's 10 rows and 10 columns. So we actually should divide this by 100 to get the average, because terms, the sum divided by the term is the average. So this would be our average, and we know 10,000 divided by 100 is 100. So the answer is C. I mean, the answer is D, because D is 100. And now let's move on to question 6. Question 6 is asking you what is the number of houses that has both a cat, a dog, and a turtle. So we know there are 2,017 houses, and then 1,820 of them have a dog, and this amount have a cat, and this amount have a turtle. So we can draw a Venn diagram, which is what we will use for this question. Okay, so let's say D is dog, and C is cat, and T is turtle. Then what we have here is that this would be a dog section, and this would be the cat section, and this would be the turtle section. So let's label them. Okay, so if the house have both a dog, a cat, and a turtle, then that means that house is living in here, because that's where all of them cross. Actually, there is a formula to describe something that we will need to use. This formula here says that if we want to calculate the number of houses here, we can apply this formula to find it. And we know that the number of houses here is 2017. Oh, we can first add up. So actually, we should write 2017 here first. We know that this is all of the houses here, and we know that A plus B plus C or D plus E plus T minus the intersections over here would be and adding the middle part would get to 2017. So what we can do is we can find C intersect with D. We want to find this term intersect with T. And then the formula indicate you add these three numbers up, which is 1,820 plus 1,651 plus 1,182 minus the intersections, which we don't know yet, but it would be C cross D, D cross T, and C cross T. So how do we reach the maximum and the minimum of the number here? So since this number, the number lower bound have to be a lot bigger than 0, because if we only fit these houses into this area, and this area, we will still have like the number here wouldn't add up. Why? Because the maximum amount of houses we can fit into these three areas would be 2017. Because there is only 2017 houses in this whole thing. In fact, let's see how it will turn out. So this number will be 4,653. And since we're actually counting them twice, because like when we're counting 1,820 and 1,651, we're counting the area here once when we're counting the dogs and once when we're counting the cats. So let's say at maximum there's 2017 houses and all three of them combined. We will minus 2017 2 times because we're over counting it once. Then we will still have 600. We will still have 619 houses left over, because we can't fit all of them in here. So this number is not 0. And in fact, that is actually just the minimum number for this number here. Because we tried our best on over counting them, and yet we still have a number left over. If we don't overcount them, then this number will only go up. Okay, so that is actually the minimum number. So let's try to find the maximum number. The maximum number is just 1,182. If we think about it, that is the minimum of the maximum number. And that is the maximum of the maximum number. Because if it goes higher, then it's impossible, because like you don't even have enough houses that have turtles. So it's not going to be higher than this number. And it couldn't be lower than this number, because there would be a scenario where this number, where this number would exist as though one in the middle. Because if you were to look at it, like you have like all the houses here. If all of these numbers of houses happens to be in here, then everything would still fits. Let's say that there's like a bunch of houses here. You just have a bunch of them with turtles and a bunch of them with cats. And we cover like the rest of it with dogs, so that like it would fit into like 2017, which they would. And we still have enough, and by then we would still have enough dogs left over to cover 1,182. To show you mathematically how that is possible, we can divide dog houses into 2 sections. One section will be having 1,182 houses that both share a cat, both share cats and turtles. And if you were to look at the rest, which would be 1,820 minus 1,182, you would have 638. And in here, you will have 1,651 minus 1,182, which would be 400 and 469. And if you add all of them up, you will see that if you add this number and this number and this number up, you will see that they're indeed greater or equal to 2017, which means there is a scenario where 1,182 houses belong to both a dog, a cat, and a turtle. So this is the upper bound, this is the lower bound. You subtract these two numbers, then you'll get the right answer, which is this number. Okay, so the right answer is C.